Hello friends, we were discussing about reduction in nonlinear distortion in a nonlinear amplifier in our previous video. Okay, and we came up with a result that negative feedback reduces the amplifier distortion by a factor 1 plus GH, where G is the open loop gain and H is the feedback circuit gain. Clear? You all know this. Now let us solve one numerical based on this topic. Before going to that, I want to introduce you with these two terms. Basically, you know this, but you don't know what is the name, which is name is assigned for which property or which parameter. See, feedback factor and feedback ratio. Okay, the feedback gain H is called feedback ratio, and feedback factor is basically G into H. That means multiplication of the open loop gain with the feedback gain is together termed as feedback factor. Okay, see, this is the negative feedback scheme. Here input parameter, it may be voltage or it may be current, and here the gain block or amplifier like BJT, MOSFET, etc. Here output, we are taking some portion of the output in this block. This is called the feedback block. Generally it is attenuator, and see, we are subtracting this signal, this feedback signal from the input signal. So it is a negative feedback scheme. So multiplication of G and H are together called feedback factor, and feedback ratio A is the H. Okay, clear? This thing you remember. This may help you in solving numericals. See, now let us go to the numerical. The question is, if the gain without feedback is 36 dB, that means according to our theory, the open loop gain G is 36 dB and harmonic distortion at the normal output level is 10%. That means the distortion without feedback is 10%. Then what is the gain and distortion when negative feedback is applied? That means we have to calculate the overall gain of a negative feedback scheme and distortion which is reduced after negative amplifier, application of negative feedback amplifier. What is the value of the distortion? We have to calculate, and it is given that the feedback factor being 16 dB. Feedback factor means what? G into H in dB magnitude form, it is given as 16 dB. So first write whatever data are given. G, that is open loop gain, is 36 dB. Here it is given. That is next 20 log GH is 16 dB. GH is the feedback factor and it is gain in dB magnitude. So 20 log GH is 16 dB, and distortion without negative feedback is 10%. See here, distortion at the normal output level is 10% is given. So distortion without feedback is 10%. Clear? Now for solving numericals, to apply the formulas, first step is we have to convert this dB magnitude into original magnitude form. Okay, so let us do the conversion. So G is equal to 36 dB. So 20 log 10 base G is equal to 20 log G base 10 is equal to 36. So G is basically 63.1. This thing you can calculate from calculator. And for feedback factor, 20 log 10 base GH equal to 20 log GH base 10 equal to 16. So that GH is equal to 6.3. Clear? So first what we have done, we have converted from dB magnitude to its original magnitude. That is the gain, that is open loop gain of the amplifier, of the nonlinear amplifier, is 63.1, and the feedback factor, that is multiplication of the open loop gain and feedback gain, is 6.3. Now gain with feedback we have to calculate. We all know that gain with feedback G dash equal to G by 1 plus GH. We know G, that is equal to 63.1, and we know GH, which is equal to 6.3. Solve this by calculator, you will get 8.63. Clear? Now we have to convert the gain in dB magnitude, because generally we express the gain in terms of dB. So what will be the answer? 20 log G dash, and that is equal to 20 log 8.63, and that is equal to 18.72 dB. Clear? This is how you all calculate. You know how to calculate gain with feedback. Now reduction in distortion, as I mentioned in my previous video. So distortion is D equal to 1 plus distortion is reduced by 1 plus GH factor. So this is the distortion without negative feedback. So now the distortion with negative feedback is equal to distortion without negative feedback by 1 plus GH. See, what is the distortion without negative feedback? Distortion without negative feedback was 10%. Clear? So that we have to put. So distortion without negative feedback is 10% by 1 plus GH. What is GH? We have converted from dB to original form and we got GH as 6.3. Solve this by calculator. You will get distortion equal to 1.37%. Clear? So see, distortion is reduced by application of negative feedback. Initially distortion was 10% without negative feedback, and now the distortion becomes 1.37%. This much amount is reduced for application of negative feedback. Okay, this I already explained in my theory. If you know the theory concept, that how to divide, what factor we have to divide, and how it came, if you have clear concept in these portions, you can solve any numerical related to this topic, that is feedback amplifier. Okay, in my next video I will show you some more concepts. Thank you for watching.